Thank you all for coming, and good afternoon to you all. Really glad you're here. My name is Nicko Gruyer. I'm a software engineer at Kaleido. Kaleido is a software startup in the enterprise blockchain space. We're actually headquartered right here in Raleigh, North Carolina, about 2 blocks that way. So it's great to be able to come speak at a local conference here. And I'm really excited to be able to tell you today about Hyperledger FireFly. FireFly is the newest project in the Hyperledger umbrella, which is part of the Linux Foundation that's focused on blockchain software for business. So really excited to introduce this project to you. This is a day of firsts for us. This is actually my very first conference speech, so I'm excited about that. And this is the first time that we're introducing Hyperledger FireFly. FireFly was, it started in Hyperledger Labs and graduated as a full Hyperledger project in the incubation phase last month. So we're really excited about that. So what is Hyperledger FireFly? That's what we're here to talk about today. It's a lot of things, but I think it's most easily understood, especially for us developers, as an API and data orchestration layer on top of core blockchain technologies. We also describe it as an implementation of a multi-party system. Now, that's a lot of words, and they're kind of businessy jargon words. So I want to spend some time unpacking that, and that's really what we're going to talk about in this presentation. So to unpack that, I like telling stories. I think it helps people understand concepts. So we're going to tell a story. So you are the main character in the story. So use your imagination here with me for a little bit. You're a lead developer working at a high-tech company, high-tech software company. You've just been assigned a brand new project. It's a greenfield project, but you need to integrate some existing systems with some new systems, and it's going to be a really big effort. So here are the requirements. Your mission, should you choose to accept it. So this is all things open, so we're going to go to space. So remember, we're using our imagination here. So sci-fi alternate timeline, we all have starships, and people are flying around the solar system, going to other solar systems. So we need a system to manage all of the data around starships. So we want to do things like we want to be able to register a starship. We need to be able to report on a starship, see different things that have happened to it. Maybe it's a transaction history of when the ship was bought and sold to different owners, maybe when it had significant maintenance or new parts, that sort of thing. We also want to be able to use this network to actually buy and sell starships, parts, upgrades, that sort of thing. So along with that comes customization. So there's a lot going on here. And all this has to be powered by blockchain. So there's the blockchain side of it, but this is not just like, well, a transaction happened in the real world, so we're going to put something on the blockchain. That's a very basic use case of blockchain. There's buying and selling going on, but this is not just another NFT marketplace where people are selling GIFs for outrageous amounts of money, as neat as that is. It encompasses both of those things and so much more. This type of network will actually use blockchain as the means to transmit data from one organization to another organization or members of the network. So who are the members of the network, you might ask? Great question. Let's talk through that. So this is what we describe as a multi-party system. So in this network, there's going to be several different organizations. First one, probably starship manufacturers. So they create a new starship, they launch a new model. They're going to register that data on the blockchain, tell everybody, hey, here's this model. Here are its features, here's some data about it. When they list a specific one for sale, it goes on the blockchain. It becomes available for sale. Next, owners. They've got to be able to see all that data, see what ships are available to buy, and actually transact on it. Local star system authorities will also probably want this. So, a ship comes into port, the authorities are going to need to scan it. Who owns that thing? Is it legally registered? Maybe what modifications have been done on it? Are those legal in this system? I don't know. Also, aftermarket manufacturers. I think this is kind of cool. So, today I could go to a website and find parts that are compatible with my car based on whatever the manufacturer said my car worked with today. But what if, as I'm adding parts to my starship now in this alternate sci-fi timeline, it's updating the blockchain and keeping it up to date to describe what parts are in my ship currently. And then so aftermarket manufacturers can look at that data and say, oh, well, here are parts that are compatible not only with your Starship base model, but all of the other additions, modifications that you've made along the way. That would be pretty cool. And lastly, insurance companies. What if I install a new autonomous flight module that makes it safer to fly my Starship? Well, maybe that could automatically update my insurance rate. That would be pretty neat too. So those are the different entities in the network. What do we need to implement to do this? I don't like putting a lot of text on a slide, so I apologize in advance. There's going to be a lot of text on this slide, but it's part of the point to illustrate that there's a lot going on here. There are a lot of features that we need to build. So first of all, members need to be able to register in the network. A new manufacturer, a new dealer comes online, starts selling things into the network. Everyone needs to know about them. So we need a registration system and a way to notify all the other members. We need to be able to define specific data types. So we need to define what even is a Starship. What fields do we require on it? What is maybe an incident report when something happens that the local authority needs to record and transmit that data to other parties? What are the fields that we need to define there? We need to be able to broadcast public data. So this is similar to registration. When certain things happen, everybody needs to know about it. It's public data, should be publicly available. We need to be able to hash and pin data to the blockchain. So if you're new to the blockchain world, I'll just very briefly describe this. So say I have a 50 megabyte PDF document. Well, in blockchain world, you don't necessarily put that entire 50 megabyte PDF on the chain. What you would do is you would take a hash of it through cryptographic methods, and then you would put that hash on the blockchain. That's called pinning it. Then you can attest later that, yes, I had this data. I put proof that I had the data on the blockchain, and you can sort of demonstrate that you had that data at some point in the past, but you don't actually put the whole data on the chain. So there's some parts that are left off-chain. Along with that, along with sort of being selective about what we put on-chain versus off-chain, there's some proprietary private data that we may not want to put on the chain. We may need to attest that we have it, but we don't want to share that with everybody. In some cases, we may not even want to share what the data was with everybody. We may only need to share that with certain parties. So we need that ability as well. That's that bullet point. We also need to integrate with existing systems. So there might be some databases that already exist, some APIs that we need to integrate with. There's going to be new things, obviously, but we need ways to plug into existing things. We need to be able to buy, sell, or resell digital assets using digital currency. So like I said, this sounds like NFTs, and it is, but it's not just GIFs. They're actual things that can be bought and resold using this network as a first-class citizen. So along with that, you could also have exchange of data with tokens as well. So not only just buying a digital asset, but the tokens, the fungible tokens, can create an economy for data exchange between different members of the network. There also needs to be real-time notifications of transactions. As things are being bought and sold, as new things are registered into the system, we need to know about that as they're happening. We need to be able to query the system to get the entire record of something. Say I'm shopping for a Starship, and I want to see the equivalent of the Carfax report on the Starship. Who's owned it? When was it made? What happened to it? I need to be able to query all of that. And lastly, we want a nice, concise REST API for performing any of these actions. So the goal here is to be able to model all the business logic in familiar web programming techniques and technologies and be able to access all this cutting-edge blockchain technology. So going back to our, picking up in our story, you're the lead developer. We've just reviewed the requirements. You've got to make some design decisions. What technologies are we going to pick? How are we going to build it? And we've got a couple of options in front of us. So option one, you can build it all yourself. That's fine. That's usually my default answer. Oh, that doesn't sound too hard. Let me just code that up. And then you get into it and realize, oh, actually, this is a lot more than I thought it was. So if we go the build it ourselves route, we're going to have to design solutions for all the features on the previous slides. Not only that, we're going to have to get all the members of the network to agree on all of those solutions, that they're a good solution, that they're secure, that they meet everybody's needs and interests. Then we got to go build all of those features. It's important to get the agreement on it before you go build it. You can sometimes do those in parallel. It doesn't always work out so well. Then we need to go deploy all of those things to each member. And then each member is probably going to have some amount of custom logic as well that integrates with their specific systems. And so they'll need to build that bit as well. So there's a lot there to the build it yourself option. Option two, which is probably why most of you are here, is to use open source software. This is all things open, so this is what we're all about. I'm not being subtle in trying to direct you to option 2 here as a disclaimer. So option 2 solves all those problems. You just deploy FireFly for each member, and each member will then build their custom whatever specific business logic they need to integrate with FireFly. So FireFly is a standardized way that takes care of all of those features on that previous slide. So, okay, maybe you're not convinced yet. Maybe you're still like, that's not that hard. How much work is it really to build that stuff? Well, I took a stab at answering that question, and I thought to myself, well, I can't really figure out how many lines of code somebody else would write, but we implemented all these things in FireFly. So I took a look at the FireFly code base, and I added up all the lines of code there. So let's walk through this. So there's the API and orchestration layer. That's really the it's integrating a database, a blockchain, on-chain, off-chain storage, a bunch of things. It's managing state of events. And so this is what we call FireFly core. That's 80,000 lines of code. So that's a good chunk of code. There's also a blockchain connector library. We'll get into the architecture of FireFly in just a second, but it's modular. So you can swap out various parts of it. The blockchain connector layer is an abstraction layer that sits between the orchestration layer and the blockchain itself. So you can actually you can swap out the whole blockchain if you want, and use a different blockchain if you need to. So on average, the blockchain connector is about another 20,000 lines of code. Private messaging layer, 1,300 lines of code. We need to exchange tokens. That's probably another 2,000 lines of code. I did a little bit of rounding here, but you can go check out all our Git repos and verify my numbers if you want. UI for monitoring the network, seeing what's going on, seeing transactions flow through the system, 4,000 lines of code. We'll want some tooling around it to make it easy to actually build apps on it and deploy it, 5,000 lines of code. If you're better at mental math than me and you've been adding these up as you go, hopefully you'll come to the same conclusion I did, and that's 112,300 lines of code. It's a good amount. If I were you in your position as a lead developer on this story and had to make a decision about what to use, I would vote for building on open source. But that's just me. You are free to make your own decision. And unfortunately, I'm not the best storyteller, so I actually didn't write the conclusion of the story. So that's up for you to write on your own. OK, and like I said, the implementation is actually the easy part, because we're engineers and we love to write a lot of code. So that's not that hard. The hard part is designing secure solutions for all of these features and then getting all of the members to agree on said designs and whether they're actually secure or whether everybody thinks they're the best way to do it. So this is where FireFly comes in. FireFly implements a multi-party system. It gives you a nice REST API. It gives you WebSockets. You can use familiar web technologies that most of us in this room have probably already used. And it solves all of the infrastructure and the messaging and the queuing and all of the event and state and really hard blockchain problems. It is a solution for those that you can just open up out of the box, take it, plug it in, and use it. And it itself is pluggable. It's a microservice architecture. So I've got some diagrams in just a second so we can look at some pictures, but it's very modular. You can swap out whole pieces of it for different implementations if you need to customize it for a specific use case. So what does FireFly look like? So on the left here, we have a FireFly network, and then on the right is kind of a zoomed-in picture of one of these nodes. So we can see each member of the network has a FireFly node. They have their own applications, their own business logic, and they have their own private database as well. So this is where they're keeping their, maybe it's proprietary data that they don't want to share with the network. Maybe it's like the most current copy of a certain piece of data in the network. So their app is maintaining their database. And then when they want to submit messages or transactions to the system, they can use FireFly's REST API. So FireFly will communicate with other FireFly nodes, and as people are sending messages through the network, they will receive events either on a WebSocket or a webhook. So it's an event-driven programming model. I'll touch a little bit more on that in just a second. Within the FireFly node, on the right side of the diagram here, there's the FireFly core. There are connectors. There are some common utilities. There's a UI and a network registry as well. And so that's sort of when we talk about a FireFly node, it's many microservices all in kind of in the same well, you can run it in Kubernetes in the same pod or things like that. So this is, it's several different processes that are all communicating with each other, and that's what we call a FireFly node. All right, so I mentioned that it's event-driven. So what does this look like in practice? So on the top, you have your application, and like I said, you have your own database where you're keeping track of the latest state of things. So the model in FireFly is that I submit a transaction to the network using the REST API. I get an ACK back. That ACK has an ID, and then I can use that ID to look up the message later. I can listen on a WebSocket to see when events are coming in real time. That may be when another member has confirmed that message, or maybe somebody actually generated another message in response to mine. So maybe I submit something, the system says, OK, yep, we got it. Now it's been delivered to another member. Oh, and by the way, now they have the next step in this big, long business process that has been defined here. And so you get another message coming in on that WebSocket as well. So as data is being updated in the system, your app would then probably keep the current state, the latest state, in your own database. However, FireFly has the entire transaction history. So if you ever need to go query, how did we get to the current state? What's the whole series of transactions? FireFly has an API that you can use to query that. So that's the event-driven model of FireFly. I also want to briefly touch on the architecture. What does it look like inside the code? Because I'm a developer, so I love talking about the code. So I mentioned that it's modular. It's pluggable. So down here at the bottom, we have the FireFly core. And FireFly core is, like I said, it's an API and orchestration layer. So the core has defined a set of interfaces, and in code, it's written in Go. There are actually Go interfaces. And so they define a set of functions that, this is what the persistence layer does. It needs to, put data, it needs to get data, it needs to query data, delete data, that sort of thing. So for each of these interfaces, you can write a plugin. So out of the box, we have plugins today for a SQL abstraction layer, and we can use PostgreSQL or SQLite. So when you're running in a local dev mode on your machine, it uses SQLite. When you deploy into production, you can use Postgres, though. But if you wanted to bring another database to FireFly, it's really easy. Just implement the few functions that are defined in the persistence plugin, in the persistence interface, and you can create your own plugin. The same is true all the way across the board, including the blockchain itself. So FireFly is designed to be blockchain agnostic. So you can swap out the blockchain implementation. You can use Ethereum or Fabric today are the two plugins that are there. But if another really cool, more efficient blockchain comes out later as blockchain technology continues to evolve, it'll be really easy to write a new connector for that and plug that into FireFly and use that as well. So at all these layers, the data exchange, data storage, even down to how events are delivered from the system is all modular. So for instance, maybe you wanted to use Kafka instead of WebSockets. Well, you could write a plugin to do that. There's an interface you can implement for delivering events, and that's modular as well. OK, that was a lot of slides. That was a lot of information. I'm going to switch gears now, and I would like to actually show it to you in action. So we're going to do a demo. And I know live demos are risky, but I'm going to do one anyway. So I have switched here to a terminal, and I'm going to use the FireFly CLI to get started here. So I'm going to type a couple commands in here and try to narrate this as I go. So the FireFly CLI, it's a Go process that you can install with Go install. And I'm going to run ff-init. And this will create a new local development stack for me here. So I'm going to call this one demo. And it's going to ask me the number of members that I want to put in this network. I'm going to say 3. And it will say, I created it for you. So you may notice we're using Docker Compose. I'm going to start this up. And then while it's starting up, I will describe what it's doing. So I'm just going to type ff-start demo. I'm basically going to follow the steps that the CLI is walking me through here. And then that's going to start up. So while that's going, it's going to do some work. This first time setup takes some time because it's doing a lot of things. So there's a Docker Compose file that defines FireFly and all of the microservices that FireFly needs to run. So it's going to pull images for those. I already have the images locally, so it's going to skip that. But it's going to set up all those Docker containers. It's also going to initialize a new blockchain for me locally using, right now, the default settings are using Go Ethereum. So it's setting up an Ethereum blockchain, building a new one from scratch. It's going to, after all these processes come up, it's going to deploy smart contracts that FireFly will use to run transactions on chain. And it will also register all of the members on the network. And so they'll know about each other. So there's a number of steps here that normally you would have to do manually, besides just like turning on all the things. You have to tell them about each other. So the CLI is designed as a developer-friendly tool to get started building apps on FireFly. So it runs on my machine. It builds an environment that's optimized for local development. So we're using SQLite. We're using one blockchain node. So consensus is really easy. It's really fast because getting everybody to agree that a transaction should go through is just one node saying yes all the time. So this is not a production-ready tool. It's not a tool designed to deploy a production network. So just wanted to make that clear. This is a developer tool designed for setting up a lean, mean FireFly stack on your own machine. I didn't mean to make that rhyme, but it worked out that way. So we are almost done here. We're now going through the process of registering the members, and then the FireFly CLI should tell us, it should give us a URL of a UI that we can pull up in our browser in just a second. Then we can start running some transactions on it. And there we go. So we told it that we wanted to build a network of 3 members, and so we have a URL for each of the members here. And you'll notice they're running on consecutively incrementing ports. So member 0 is on port 5000, member 1 is on 5001, member 2 is on 5002. So we're just going to open up those things here. That didn't open in the tab that I thought it was going to, but that's OK. I'm just going to open all these up, so we'll have them to refer to. OK, so this is the FireFly Explorer. FireFly Explorer is a read-only view. It's sort of a way to inspect what's going on inside the FireFly network. So you can see right now we have 3 members. Is that? I'm going to make that a little bigger. Sorry about that. OK, so we can see we've got 3 members in the network, and no messages, no transactions, no data. That's fine. That's what we expect. We just turned this thing on. So nothing's happened on it yet. I'll also show you. So we can go. If we want to see what we can do with the thing, instead of going to /UI, we can go to /API. And this is a Swagger document that's actually generated by the code at runtime. So if you pull up this page, if you start your network, you can go to this page. This is always up to date. It's actually, like I said, being generated on the fly by the code itself. So it's sort of self-documenting in that regard. And as we add new endpoints, they automatically get added to the Swagger, which is really cool. If you've ever worked on a project where your API spec had trouble staying in sync with your code, FireFly shouldn't have that problem. And we even have checks in the CI/CD to make sure that it doesn't. So I'm a fan of that. Anyway, so if you're curious about all the endpoints, you can go here and look through them. There's a static version of this that is posted in the doc site that just reflects whatever's in the latest in the main branch. OK, so that's a quick peek at FireFly. Let's actually run some stuff on it now. So I'm going to hop over here to Postman, and we're going to continue our Starship story here. So the first thing I'd like to do is define a data type. So we want to define what is a Starship in our network. So we have an endpoint that we can do that with. There's a data types endpoint here. We're going to give this data type a name, and we're going to give it a version here. And then the rest of this is using JSON schema. If you're not familiar with JSON schema, it's just a way to define what a JSON object looks like, what fields it has, what types they are, that sort of thing. So that's a standard you can go look up. That's what FireFly uses to define data types. So we're going to tell it, we have a serial number. It's a string. It's a unique identifier for the Starship. We have a manufacturer, a model number, and a manufacturer date. I'm sure if this were a real thing that there'd be a million other fields that we'd want in here. But this is all I could think of in the 5 minutes that I thought of this as I was putting this data type together. What is a Starship? So let's submit that to the system. OK, so we got an ID. And this data type has been defined in the system now. So now I can call the API to list all the data types as well. So this is now just a get on that same URL. And I can see my data type is there in the system. And so all of the other members will know about that data type now. So all we've done is we've just defined this is what a starship is in a very abstract sense. We haven't actually put any meaningful data in there. So let's do that now. Let's upload a starship. So now we're going to make a post to the data endpoint in the default namespace. And we're going to tell it that this is of type starship and the version. And then we give it a value. And so we've defined a serial number, manufacturer, a model, and a manufacturing date. So we'll submit our YT model light freighter here to the system. We'll upload that. And when you upload data to the system, if you define a data type and you specify it when you upload the data, it will actually run a validation check on that to make sure that you met all of the requirements of that JSON schema that's defined. So it'll help prevent bad data from getting entered into the system. All right, so we got an ID back for that piece of data. Nobody else in the network knows about this yet, though. Oh, I forgot to mention, so, and this will become relevant in just a second. You may notice I'm using some variables here. If you're not familiar with Postman, this is this stuff in double curly brackets is filled in by an environment here. And so I have a couple of environments set where I can switch between members of the network. Actually, this is, there we go. That's the button I was looking for. So that FireFly base URL is just telling it, send it to member 1. I meant to select member 0, but that's fine. So that's if you see curly braces around in the demo, that's what that's all about. OK, so we've submitted it. So we've added it to member 1. And nobody else knows about it yet, though. So if we go back to our browser and we look at like member 0 and go to the data tab, nothing here, no messages. So now let's tell everybody about it. Let's do a broadcast. So pull up the requests for the broadcast here to send data. All right, so this is going to be a post to the broadcast message endpoint. And what I'm going to do is I'm going to copy the ID of the data that we just uploaded and put it here. So now I'm telling FireFly, hey, that piece of data that I uploaded earlier, I want you to tell everybody in the network about it. I want them all to have a copy of it. It's public data, so send it to everybody. You could also inline the data right here. You don't have to specify it by reference. But so you could just put a JSON object right there if you wanted to. If you want a little bit more control of it and you want to reference that thing later in other transactions, though, it's helpful to have the piece of data itself have its own ID separate from any messages about the data. So I'm going to send that data now, and I'm going to send it to everybody. And I should be able to go back to my UI here. And there we go. There's some data. So now, so that was member 1, just broadcasted that to the network. And here I'm looking at, this is member 0. Make that a little bigger for you. And we can see that piece of data that we submitted earlier. Just for the sake of the example, we can go look at member 2. They see the broadcast as well. We'll go into the data tab. There's the same piece of data. So now everybody in the network has a copy of that data. And they can see that that data is there, that Starship has been registered. OK, well, that's great. What if we want to put some data in the system and we want to tell one member about it but not the other? Let's give an example of sending a private message now. All right, so let's say we had, as we were traversing the stars, we entered a system and we had maybe some cargo that we weren't allowed to have in that particular system. So that's bad. So we get an incident report. That goes on the blockchain. But the data about that report is not public to everybody in the network. But maybe the local star system authorities need to tell the insurance provider, hey, this thing happened. That's going to impact your rate. Just go with me here for the sake of the example. So we're going to post another piece of data. I'm not going to define a data type for this one for the sake of time. I'm going to link in the body of this one, I'm going to reference the data ID of the Starship that I uploaded earlier. And so here we'll just, we'll upload some data with a timestamp, some really random made-up XYZ coordinates that may correlate to some point in space. I'm not an astronaut, so I don't even know how you define where you're at in space. That is above my pay grade. But for the sake of the example, here we go. All right, so we uploaded that piece of data. Again, we'll get an ID here. And now we're going to grab this ID, and then we're going to, instead of broadcasting it to everybody, the key difference is here, we're going to send a private message. So I'm going to, just like I did earlier, I'm going to put the data ID of the thing that I'm sending right here. You'll notice this is a slightly different endpoint. Instead of broadcast message, now we're going to do a send message. And we're going to add a header this time. This is optional, but there's a lot of other things you can send with a message. So this header includes a tag that says process new incident. So that's just a way of one member telling another member, hey, I'm giving you this piece of data, but here's why I'm giving it to you. Here's what I want you to do with it. Here's the reason I'm sending it to you. So you don't just get a random piece of data and go, what do I do with this? So the tag allows you to give you some flexibility there. And the other new thing here is the group. So the group is an array of one or more members and their ID. So other org name, just if we look again at our variables, is org0. So in this case, org1 is going to send the data to org0, and org2 should be completely in the dark that this transaction has happened, that they're sharing this data, because this is a private message. So we'll go ahead and send that. All right, we got an ID. And just for the sake of the argument, let's go here and look at org0. So org0 has a new piece of data that came in. We'll see, OK, here's our incident. They were transporting Rathtars, apparently. And we'll go here and look at, so this is the one who sent it. So org1 and org0 should both see the data. And in fact, they do. So here's 0 and 1. They both see it. But this one, org2, doesn't see the data. And just to prove that I'm not just refreshing the page to lie to you, I'll refresh it. And it's just not there. So that was a private message. So the first two orgs can see it, and the other one can't. There is a lot more that FireFly can do. There's a whole token exchange. You can mint tokens. You can transfer them. You can burn them. I would love to get into all of the different things you can do with FireFly. Unfortunately, we don't have time to go through every single endpoint today. There are some other great resources in our wiki and our docs that go through all the different things that you can do with FireFly. And if you're interested, I encourage you to check those out. So I'm going to go back to my slides here. I have 2 more slides, and then I'll wrap up. All right, so this was kind of a fun example. I like sci-fi. I like Star Wars. But do people actually use FireFly? Does this type of thing, is it actually useful in the real world, in today's non-alternative sci-fi timeline? And the answer is yes. So multi-party systems, as hopefully you've been able to kind of make the mental leap from my cool sci-fi example to the real world and where this might be useful. So anytime you have different either companies or organizations working together with varying levels of trust. So we'll take insurance agencies, for example. They need to work together. They need to perform transactions. They need to exchange data. They may be competitors, though. So there's a lack of trust there. And not only that, they have proprietary data that they need to keep proprietary and private. So that's one example. There's a lot more that I could talk about, though. But anytime you have multiple organizations or entities working together in a network, and you want to power all of that with blockchain, this is exactly in FireFly's wheelhouse. So that's what we mean by a multi-party system. So there are, in fact, today use cases and companies building real apps on FireFly in the insurance industry, in healthcare, real estate and finance, and also in nonprofits and charities. There's a really cool one that it's another open source project that I've been helping kind of and technical advising on, where some folks had the idea of, like, it would be really cool to use blockchain to help create a safe, auditable system for donors to donate things to people in need, and to be able to track that using blockchain, have it be auditable, have it not be able to be mutated on the blockchain. And so it's a really cool application of it, and also an open source thing. So I'm really excited about that part too. I'd like to conclude today by extending an invitation to get involved in the FireFly community, even if you don't know anything about blockchain. In fact, I will say before April, I had never written a blockchain app. I had never written a line of code that used blockchain. I had tried mining on my GPU, quickly did the math and figured out that that was not going to be effective with the GPU that I had. But I didn't know a lot about blockchain. So there's plenty of opportunities to get involved in FireFly, even if you're not a blockchain expert. There's space for people to get involved at every level of expertise. And there's a variety of languages used in the code base as well. A lot of it's written in Go, but there's also some TypeScript. It's also modular, so things can be written services can be written in different languages as well. It's a new project, so it's a great time to get involved. There is a big opportunity to make a meaningful impact in the community and in the project. So we would love to have more people joining the project. That's why I'm really excited to be able to talk about it here today. If you want to get involved, you can check out our code on GitHub. You can also join our Rocket Chat. It's like Slack, but not quite as user-friendly, as I like to describe it. But all the maintainers are on there. It's a great place to join and just ask questions directly to the maintainers, talk about FireFly. And then another great place to get involved is in our open community calls. So every other week, we have a Zoom call where we usually have like 3 or 4 maintainers on there every week. We'll talk about what's going on in the project, what big new changes are coming down the line. It's a great opportunity to get feedback from the community, from people that are using FireFly on, like, hey, I'm really excited about this thing, or hey, it would be great if FireFly had this. And we love to get feedback from people. And it's an open forum for people to discuss FireFly, talk about how they're using it, and talk about the project. So definitely encourage people, if you're interested in it, join our community calls. It's on Zoom, it's free, it's open. And yeah, everyone is welcome. We would love to have more contributors. We would also love to have more maintainers. So if you're really passionate about it and want to get in on the long haul, let me know. I would love to get you connected. Again, my name is Nicko Gruyer, so you can look me up on Twitter or LinkedIn. I'm N Gruyer. That's N-G-U-Y-E-R. Would love to get to know folks and help you get involved if it's something that you're interested in. But thank you very much for coming out today. I really appreciate your time and being able to speak to you. It is a pleasure. So thank you. And I think we've got a few more minutes for Q&A, but thank you very much. All right, the floor is open. Questions? Sure. Yeah, good question. So I think there's some folks listening online, so I'll repeat the question. So why would an organization choose blockchain or FireFly instead of a traditional network? I think, is that, okay. So yeah, great question. So many people think of, when they first think of blockchain, like, oh, that's Bitcoin. Well, that's because that's really what made it well known. Blockchain is a lot more than that, though. It is so the same cryptography and distributed immutable ledger is actually a really powerful thing for businesses. And so I look at it like anytime you need a distributed ledger. So you think of a transaction history or a history of updating data in a system, and that history needs to be preserved, and it needs to you can't change it. So that's the immutability of the data on the chain is a really compelling attribute. The other thing is the distributed nature of it. So not one organization in the network owns the data. So for these types of networks so we'll go back to the insurance example where you have a transaction history between 2 clients, each on a different organization, and there's potential conflict of interest there. And so having everyone have the same copy of the data on the chain is really valuable because everyone can see it, everyone can audit it, and no one person can go make a change to the transaction history, and everyone else would be aware of that. So hopefully that answers your question about blockchain. For FireFly in particular, it's, I think we look at that list of things to build. So just like, so say you were convinced you wanted to go with blockchain. Okay, great. But I just deploy a blockchain node, you deploy a blockchain node, and then what? Well, we still have that whole slide full of all those features that we need to go build. And so that's the value that FireFly brings. It brings a whole layer on top of that solves messaging, queuing, handling events, and gives you a really nice API. If you haven't done any blockchain development, there's a whole lot to learn. There's domain-specific languages. There are APIs that are not nice to use. Some are nice to use, but then there's some that are really not nice to use, and it's really a lot to set up. So FireFly is sort of the, hey, we have a solution for all of those things for you already, and you can just focus on building your app, building your business logic, and using this API. So hopefully that answers your question. Yes? Mm-hmm. So, so the blockchain. So the question is, how do you reconcile using blockchain and everything's public with sending private messages? Did I just circumvent the blockchain there? I think is what you're getting at. It's a great question. And there's a lot more material on like how privacy works in FireFly. The short answer to your question is no. I still use blockchain there, but all that you'll see if you go look on the blockchain is an Ethereum address and a hash. And the hash is really meaningless because no one else has access to what that hash actually represents. So in the case of the broadcast, anyone in the network could look at that hash on the chain and then go look up, what does this data point to? In the case of the private message, there's nothing to go look up. Only the two members that were actually sharing that private data actually had the original data that they could look at that the hash represents. Does that make sense? Okay. Okay. Yeah, so like I said when I described pinning a little bit, the data itself doesn't actually go to the blockchain. Yeah, the data is somewhere else. So the payload is kept off-chain. So what we're putting on-chain is the hash. Yep. Yep. So the other party could still, if they just looked at the raw blockchain, they could still see a hash that was on chain, but they would have no idea what it related to. And if we get into the details of how FireFly batches transactions and things like that, there are some things in there that help even obscure even who was sending the transaction to who they were sending it to. Yeah, great question though. Yeah. All right, we got 1 or 2 minutes left. Any other questions? All right, well, thank you very much. I really appreciate your time, and it was great to be able to speak with you all today. Thank you very much.